In this video, I'm putting together a high precision laser air quality sensor. It's a PMS5003. I'm also using a SHT21 temperature and humidity sensor. On this sensor, the positive wire is black and the ground wire is red. There's only 3 wires you have to use. You have to use the TX, ground, and power wire. I wired the TX wire to the D4 pin on the D1 Mini. I soldered the ground wire to the top of the ESP chip because I used the other ground for the sensor. I soldered the SHT21 to the top of the LCD screen. I'm using a wire wrapper to put the wires around the pin on the LCD screen. I wired the SDL pin to the D1 pin and the D2 pin to the SDA pin. Here I'm using Tasmota, changing a few options because the LCD firmware doesn't have support for the air sensor and the sensor firmware doesn't have support for the LCD. So I removed a few things and added a few sensors to it and compiled it, and I'm uploading it to GitHub. Now it compiles fast because I already compiled it. Now Plant.io is going to upload it to the D1 Mini. Now connect your Wi-Fi to the ESP chip. Once connected, you put your Wi-Fi settings in the chip. Alright, enter your Wi-Fi settings in. SSID and password. Save. I'm using Minicom hooked up to the serial so I can see the IP address. Alright, so now it's connected to my router. Set it to generic. Save settings. D1 to SDL, D2 to SDA, D4 to the air quality sensor. Here we load the template right in, save the template settings. Now it says Air 2 module instead of generic module. You can see the temperature and humidity sensor on top of the LCD. Now you can start seeing the stats of the sensor. Now I have to add 2 rules. For some reason I couldn't fit it all in one, maybe it was too many characters, but I made 2 rules to display the information on the LCD. It displays the temperature and humidity and the 3 basic size 1, 2.5, and 10. And I added one other 2.5. I'm not sure how to say the actual numbers. I blew some smoke over by the sensor, that's why it went up to 6,000. Now you can see a quick graph for the last, I think maybe 12 hours in Grafana. Every time those peaks are is when I blew smoke towards the sensor. I loaded all the purple air sensors for my county. The top meters show you averages. Right now it's set for 1 hour. Right now it's set for 12 hours. The purple air sensors are like $260, so I decided just to build my own. The one on the bottom is the sensor. Now I'm going to back up the Tasmota with the ESP tool using the read flash function. I'm backing up all 4 megs. Now I'm opening up ESP-home. Now I'm opening up ESP-home. It's a simple YAML sketch. You just have to add I2C, the 2 sensors, the one for temperature and humidity, and the air sensor. I'm uploading the code to GitHub, and I had to write a few lambdas to display the LCD information. Now I'm going to compile it, but it's already compiled, so it goes pretty quick. Now I'm going to download the firmware and upload it on my laptop. I made a simple script to upload the firmware with the ESP tool, which is a native tool for an ESP chip. It uploads anything in the folder that's this name .bin. You gotta make sure there's only one file in the folder when you do that. After uploading the firmware, the script loads MIDI-COM. Now you can see the sensors already pulling in data. Now you see in the ESP chip is hooked up to Home Assistant right now. That's where it gets the time. And with the ESP Home, you could change the fonts, and you could also easily change the text size. I'm not sure if you can do that in Tasmota. And you can see that the LCD numbers move in real time. I just blew some smoke on the sensor, and you see the numbers go up real quickly. This setup doesn't flash like the Tasmota setup. Alright, it's going back down. The LCD only flickers in the video. Now you can see both displays side by side.